Hello, everyone. Welcome to the GIS in Action Session 1. We're thrilled to have you here for the first breakout session for the ADEQ conference. We have 3 presentations in this session, so I want to make sure that we have time to do them all. I'm going to just do a quick reminder. When you're done, please make sure you when we're done, complete the session survey. The recording of the session will be available on this page within 2 hours after this session ends. And to connect with speakers, if we don't happen to have time to answer all your questions, go ahead and use on the Attendee Hub, the community, under the attendee list, and find your presenters there, and you can send them messages through the system. We'll be monitoring the chat and the Q&A. Oh, I have the wrong slide up, I'm sorry. Anyways, there's the welcome slide. Anyway, so I'm going to go ahead, since we have a limited time, and I'm going to turn this over to our first presentation, which is the mobile compliance inspections for waste programs. And I'm going to let Debbie, Julie, and Brenna do the introductions and get started.
Thanks, Jamie. So I wanted to just introduce all of us at once. I'm Julie Mikolajczyk. Myself, Debbie, and Brenna are part of the GIS team at ADEQ. Our mission is to protect and enhance human health and the environment in Arizona. Debbie's been our primary technical lead on this particular project, the move actions since the project began, so a few years now. Brenna moved from intern to technician about 18 months ago, and she's been able to create dashboards, automations, web applications. And I joined the team in February 2020. I was lucky enough to meet everybody right before we went home in March. But we're excited to talk to you today about our project. And I look forward to, or I encourage you to look at our bios if you wanted to get more information about each of us. Debbie?
Yeah, can you see my screen?
Yep, looks good.
Okay, good. It didn't look good on my side, so. All right, good morning, welcome. I always love coming to ADEQ. It's a little bit better when it's actually in Prescott and we have a chance of rain, but since we're stuck wherever we belong, then we'll have to make do with our weather here. We're excited to present how we have used Survey 123 and its auxiliary apps to inspectors more efficient and do as much of their work automatically as possible. So the problem that we had, part of ADEQ's responsibility include regulating thousands of waste facilities, USTs, which are underground storage tanks, landfills, hazardous waste dumping, all of the things that are gross and nobody else wants to deal with. That's our job. So our biggest problem when we started was we had the inspectors just using clunky laptops or clipboards and papers out in the field and everything, and we had a difficult time getting through IT that sometimes those laptops and stuff that they were trying to take out in the field were a little bit clunky, tended to fall apart. Batteries didn't work right. There was all kinds of problems. So as we were able to move our inspection force to iPads and phones, they were able to move in and out of places where they couldn't use laptops and not carry so much of the things with them. So what we used to do is they had paper files manually pulling from the database, and with our underground storage tanks, this stack you see here may be just for one storage tank that happened to be leaking. So the paper mound was just out of control. So what we did was we started with Survey 123, and we were able to auto-populate some of the information from CSV if we had it in there, or we later were able to work to pull data directly from our Oracle database. So here's an example here of one of our surveys that we had for the landfill matrix. And we were able to, if we knew the facility ID, In this case, it happens to be 783. We could put that facility ID in there, and it would auto-populate all of the other information that the inspectors needed to have. And they could do this. You have to have a connection to begin with, but once they're out in the field, they did not need any further connection. So field work was taking all of these things out in the field with them. They had to have cameras, their laptops, their phones, all kinds of different things. And we were able to streamline that so that there wasn't very much office pre-work, and they were able to have just one device with them that would contain all of the data and be able to take photos and allow the inspectors to come and go in places that might not be ideal. So let's see what it looks like. I went out on an inspection with some of our solid waste people on a municipal landfill inspection. So the inspectors arrive on site with their facility information is already populated, and that was done automatically, again, through the Survey 123. They can take photos of documents that will stay with the report as they interview the responsible party. The iPad can take photos, and all of that metadata that goes with the photo, I'll show you a little later, can be connected with that photo and always stays with the photo and with the report. In various conditions, this happened to be after we had a rainstorm. This is out in Glendale, one of the few times we actually had rain, and we were grateful that we didn't have to carry a lot of different devices and stuff around. This inspector just had the iPad and was able to walk around and go to the edge of the puddles. So the survey questions are the way that they're asked during the inspections. It keeps them all on track, and there are relevant questions, as in if they asked a question and the answer was yes or no, that depended on what questions were used to follow up from that. And it keeps everybody on track and makes sure that all the questions are asked. Inspectors can quickly go through the questions and then bounce back and forth between the photo log. So if they have a question, want to take a picture right there, they can take the picture, a couple clicks, and they're back in the survey. The survey and the photo log are together, but they just pop back and forth with 1 or 2 clicks and stay on track. So documentation happens on the spot. This happens to be, like I said, this was a landfill, and the orange thing shows that it happens to be methane. This is like a windsock, and this is actually perfectly normal in a landfill. They do methane, but this is a capture system that goes over here and gets treated. So the photos can be used to prove compliance or non-compliance, and again, they're right there on the spot with the responsible party and able to ask any follow-up questions that they need for that. So the process that we used, we started with the units forms that they were using in Word and built the survey in Survey 123 Connect. Then we made templates for the reports, and when you go into arcgis.com.survey123, you can print these reports, and out pops all of the information, even including checkboxes with yes, no's, and with relevant questions. It comes also complete. This happens to be a place where the responsible party needs to initial, and so all of those things are taken care of within Survey 123. Surveys can be customized to trigger questions, as in this question, if there's a no, then all of the following questions in this section will be NA. We had several different versions of these, whether it's yes or no, or if they completed the fix while the inspector was on site. You can also use CAN language, and where the bold type is here, those things are pulled from answers from the Survey 123 and dropped right into the end report, so that you can use CAN language, and then the inspectors can just click their cursor at the end and add any more text that they wanted to make clarified. So this includes the photos that can be watermarked with location, direction, time, any kind of things that you are going with in the survey. can be used. And here's a close-up of that. You can see we have a lat long in here, the actual direction that the device is pointing when you take that picture, the date and the time. And also you can fill in anything that's in the survey, whether it be the facility name or who the photographer is, the date, all kinds of different things can be put into the watermark. And those watermarks are permanent within the photo. So if for some reason the photo is removed out of that, all that metadata is still there. So the report comes complete with signatures, photos, checklists, comments, all the legalities of anything that is needed within the report is all in one place. And then we take that information and we turn it over to Brenna and let her take care of it from there.
Thanks, Debbie. I'm sorry, can you guys hear me?
Yes.
Okay, cool. Thank you. So if you're familiar with Survey 123, you may be familiar with manually exporting reports after a survey is submitted within Survey 123 at arcgis.com in that top screenshot shown. So with multiple inspectors in the field, we needed a way to easily provide the inspection reports to them in order for the reports to be field issued. To achieve this, we use Integromat. This is an external app that can automate tasks and processes after a survey is completed. The Watch Survey module is used to automatically trigger when a survey is submitted, and the Create Report module generates the report. Next. For solid waste, I set up a scenario to generate all necessary reports and upload them to a Google Drive folder. The folders are named with information from the survey, including the inspection ID and facility name. The inspectors can go to the Google Drive folder and download the reports while in the field and send them to the responsible party. Next. For UST, their scenario automatically generates the reports and emails them to the inspector and the responsible party when the survey is submitted. The content of the email can be customized and attributes from the survey can be used. We use the inspection ID, facility name, and other information in the subject line and in the name of the attached report. Next. So scenarios can be simple and they can be built to only complete one task. The scenarios are a lot like Model Builder. You can use the output from one module as an input for another. We also use Integromat to interact with Trello boards, which are online flow boards that are used to manage our work. The Trello boards used within the inspection units track all of their inspections. Each inspection has a card where the information is stored and the progress is tracked. Card checklists can be completed on cards, new cards can be created, members can be assigned to a card, and more using Integromat. Next. Scenarios can also be complex and can be built to complete a variety of tasks. Filters can be used to control if a task is completed or not. For example, a Trello card is only created if a violation is identified during an inspection, and the inspection report is only emailed if a field is checked in the survey. They can be customized and configured for the customer's needs. And then I'll hand it over to Julie to wrap us up.
So the solid waste team saw some great improvements in both efficiency and accuracy. Their field time was reduced consistently by 28%, and post-processing, the QA/QC manual data entry was reduced by 26%. Next, please. So one of the biggest pain points for the solid waste process was when we were trying to make a change in the survey, it could result in overwriting the data, publishing an entirely new service. And I thought IT created some Python scripts that updated the Oracle business database we call Azurite with the inspection results. That was not always 100% reliable. So we were looking for a different process. Next slide. So the Can you guys hear me? There we go. Sorry about that. I lost audio. So this is our GeoHub. We call that, we just launched our enterprise system this summer. We call GeoHub, and we wanted to try using that instead. Perhaps we could use some better triggers, stored procedures, so we could talk Oracle to Oracle. And GeoHub does give us 50 additional named users. Next slide, please. So that end-to-end solution, we wanted to be able to enable the inspectors to have all of their pre-work done and their post-work all within the Survey 123 application. So we had our Iko, our developer, she created some JavaScript code and used the pulled data in Survey 123 to connect an Oracle database view with live data into a feature layer. And then we used that in our SDE. And now you can see on the slide here, they can do this automatically. They just select on pending inspection and everything is filled in for them automatically. This improved the workflow from the CSV slightly. So we were looking for that enhancement. Next slide, please. So there's some things that we did learn along the way. One is that this is not a plug and play. We couldn't just take the Survey 123 for solid waste and convert it into UST. We also didn't really we're working on figuring out how we can make that happen. Hosted schema, moving from hosted to SDE schema, there were some challenges there. And there are also some quirks with our Oracle setup, just some limitations that occurred in Oracle that took a bit to figure out what was going on. Our enterprise setup was challenging. The report service did require the enterprise to be public facing, which we hadn't set up ahead of time, and not doing it ahead of time actually caused a lot of problems. So we want to make sure that we call that out for you guys if you're looking to do something similar. And we're also developing as we go, or learning as we go. So the development is taking longer. Next, please. I just want to close with a few of the, improvements that we've seen here. Time spent on pre and post is cut in half. Better customer service is resulting in faster delivery, fewer mistakes. Equipment flexibility, we don't have to stick with just the laptops anymore. There's more consistency, and we'll see this even increase as we integrate systems across the agency. Next slide. And I just want to, I already called out Iko Condon. I just want to make sure that we give her some special credit here, and everybody else on this slide has really participated and assisted us. And then this is just our closing slide. We've gotten some great internal and external recognition for this. So we appreciate the ERISA award that we recently received and the Esri SAG award. And that's it. Any questions?
Hey, Julie, I think we probably are getting close on time. So I'm thinking what we can do is there are a couple questions in the Q&A, and I'll relay those to you guys, and we can respond to those. You guys can respond to those in the Q&A, and I'll translate those in there for you. So those of you listening in will we will still get to your questions. So feel free to keep putting those in the Q&A if you have more for these guys. That was a great presentation. What a great project. I loved how you shared how the whole thing worked and how you went about it and went through all the steps and your lessons learned. That was really great. I really appreciate it. And if we were live, we could all be standing up and giving you applause, but we're not live. So what I'm going to do without further ado, and again, you guys, we can, for those of you tuning in, the attendees, you can put your questions in the Q&A section rather than the chat, because I'll see it more in the Q&A. All right, so next up, we have Aryn Musgrave, and Aryn is going to talk to us about using GIS to manage and develop City of Phoenix parks and preserves. And Aryn is currently the GIS technician for the City of Phoenix Parks and Rec Department. She received a Bachelor's of Science in Anthropology and a Master's of Sustainable Solutions from ASU. And her goal is to pursue a career in GIS and natural resources and wildlife conservation. So Aryn, I'm going to let you unmute yourself and share your screen, and we can get rolling. Aryn, you're going to need to unmute so we can hear you. And share your screen. You're sharing, we see your Windows desktop right now. Aryn, you need to unmute. Aryn, we can't hear you. You're muted. Okay, it seems we're having a few technical issues. Aryn is. Apologies.
Hey, can you hear me?
Yes,
Okay.
yes, we can hear you now.
All right.
And we can only see your Windows screen. I don't know if the blue screen, if that's what we're supposed to see or not.
My screens are a little backwards. I'm trying to drag it onto the correct screen here. All right, can you see my screen now?
There you go. We're good. I think we're
Awesome.
good.
Thank you. Okay, sorry for the delay. So I am the GIS technician for the City of Phoenix Parks and Recreation Department. And I want to tell you guys a little bit about our application called PLAI. And it's how we keep track of everything using GIS in the city. So PLAI is an acronym, stands for Parks and Land Asset Inventory. This first little clip here is a screenshot of PLAI as you open it. And PLAI was created in 2018 to collect and manage information about the city's parks, preserves, and facilities. Our database contains thousands of our assets, including over 7,000 light poles and 5,000 site furnishings. Just really helps us keep track of the condition of these assets so that we can maintain them. We have 259 properties, 33 community centers. There's just a lot of things to manage. So this has really helped us keep good track of everything. And just to give credit to the original creators, Logan Wagner was the GIS technician that was in charge of developing this application, along with the Parks and Development team that I work with now. So you guys are familiar with most of this, standard web application tools. So we've got navigation tools and analysis tools, and these really help our staff and employees access the data and manipulate the data in ways that help them find what they're looking for. So I'd say one of the most often used tools is the query. So we ended up making a lot of preset queries to help them. So for instance, there's a preset query so you can find all the basketball courts or all the playgrounds or listing all the parks in a specific division. So teaching the people of our staff how to use all this has been a challenge and an adventure in one. But we kind of explain, it works similar to Google Maps, and they kind of get excited about being able to do all these cool applications and analysis with our database. So one of the really great things about PLAI is that it's designed to show all the features at appropriate scale. So this is a little bit of a zoomed in version of the first shot that you guys saw. So as you can see, you start to be able to view more things on the screen. So you can see little icons for our dog parks and community centers and pools. Different outlines appear as you zoom in. So we have our facility types, as I listed. We've also got some trails that you can see on the map. And then finally, the park types are outlining the parks. And as you keep zooming in, you just keep getting more and more details as well. Now I'm going to show you guys some of the layers that we have in PLAI. Just to go a little more in the weeds. Each layer in PLAI is unique and was designed for the specific feature it represents. So they all have attributes that are really representative of that exact feature. They're all joined using the property name field. So that's how we know exactly which park they're all at. These are hosted through the City of Phoenix GIS Enterprise System, which I heard in the previous presentation was a challenge to work with and learn. That stands true for me as well. So there's just a lot of data in here. As you can see, we've got some custom symbols. Our furniture is individually symbolized. So as you zoom in, you can see what you need to find. You've got bike racks, benches, tables. We've also got unique symbols for things such as the basketball courts and community centers. And right now we're in the process of making a new layer to add to this for our signage, which will include like trail signs and code of conduct signs at all the parks. Now I'm going to show you guys what one of the attribute tables looks like. So here we have an attribute table. This is the tennis and pickleball courts layer. And it lets us see, this happens to be Cesar Chavez Park. Lets us see we've got 8 tennis courts here. So we have like our feature type. We've got ratings, which I'll explain in a minute. Helps us keep track of the conditions of the assets. And then these are some of the attribute specific fields. So we've got details about if they have lights, if there's, let's see. Yeah, lights, ratings, if the dates of the courts last being resurfaced. So all this information just really helps us know like what needs to be fixed each park, and helps us keep track of the dates of the last maintenance as well. So I mentioned the rating system. So each of our parks, each feature actually has its own rating from 1 to 3. 1 means pretty poor condition, needs to be replaced immediately. 2 is fairly good. And then 3 means it's either a new asset to the park or just still in really good condition. Again, to help us know when to replace things. Light poles, as you can see in this image, have their own rating system that's color coded, which is really nice because you can just view at a glance, like overall, does the park look pretty green or red? So each one has its own little color coded dot. Red means poor condition, green means great. And then we've also got an additional purple one, which means that a pole has been removed entirely, which could either be replaced or just deleted from the database if we're not going to put a light pole at that location again. And then just to give you a few more examples of other layers, here's a furniture layer. This shot was taken at Harmon Park. So we've got some barbecues up on the right-hand corner here, a table at the lower right, locations of benches. And as you can see, we've got ratings for each of these things, the date it was rated. We've even got information about like the brand and model of these things. So when they're going to be replaced, it's easier to say, oh, we need to consult this company again for replacing it so that the furniture looks consistent at each park. This is an example of one of our archery ranges, which is kind of cool. I don't know if you guys knew Phoenix had those. This is at Papago District Park. So just showing the layer here. We have another one at El Oso Park. It's got its rating, how many targets it has, what the surface type is. So it just kind of lets us know, what's there without actually going there. Finally, here's one for playgrounds. So this one is at Pecos Park. You can see again, we've got manufacturers, we've got a rating for each one, information about what type of structure we have there. So what ages, what age range this playground is intended for. So yeah, just a really good visual representation and then the data table to accompany that. So we used the collector app, if you guys are familiar with that, to collect the original data back in 2018. Now we use the field maps application. So if we need to collect new data, we go out to the park on site and use the app to collect data. And we try and do this every 2 years to just make sure the data integrity stays good. And we kind of go out to sites as needed as well. But this really helps us out in the field to just really, stay connected. So we can view all the furniture and lighting just on the app. Also, just because keeping the database up to date is like a full-time job, we can edit from the computers at work, at the office. And we have this application called PLAI editing, where certain staff from the division are tasked with helping me to keep the database up to date. changing ratings as needed, or replacing, removing, adding furniture as they learn that that is happening at the parks. So these are kind of delegated throughout the divisions for people to help me keep the database updated, because there's just, again, so many things that need to be kept track of. So this happens pretty much daily. We're in there making sure that things are up to date. So to help with this, I've also created recently a story map that our staff can access, and it's a training guide for PLAI. Gives really explicit directions for how to do the analysis, what to look for, just how to use each tool, essentially, to make it a little easier, because people sometimes have trouble or get intimidated by the application itself. But we want to make sure they know how to use it and access all that information. And then finally, these are just a couple other applications that are in the works. I'm working on a database for our aquatics division as well that's more specific to what they need. A database for our natural parks and preserves that's more specific to like trail needs, and a city buildings database, which is more about just like, the specific types of buildings that we maintain as well. So those are just a few more things that are in the works. And that is all. So thank you. Any questions?
I am looking through here to see if we have any specific questions in here for you. I don't see any at the moment, but that doesn't mean they're not gonna start coming in here. I think I did want to say I'm really loving, this is one of my favorite things, is GIS in action, to see how everybody's doing different things. I wanted to comment. I think that's a great idea to use the story maps for teaching people, and like a document, the help document for them, and instructing people how to use it. So I think that's pretty cool. So if anybody has any questions for Aryn, if you want to put it either in the Q&A, would be ideal, and we can have Aryn can respond to those as well in there. I'm looking through here, very detailed, nice projects. I can see in the data. I think one just came in. And they get a link to your story map training for the PLAI. Is that available?
Yeah, absolutely.
Okay. If you want to put that to me in our internal chat here, I can transpose that into and share that with everyone on the in the portal there. Another question just came in. How long was the data gathering for Phoenix? Do you have a complete inventory? That's pretty impressive if you do.
So I wasn't there for the original gathering, but it did pretty much take a full 2 years. So 2020 was when they finished collecting all of the data, and I joined the city in December of 2020. So at that point, we were just getting ready to start reviewing the collection again, doing those biannual surveys that I mentioned. I don't think it will take as long to do the surveys. We're not going to go to each park individually anymore, which is what took so much time, because there are 200 and almost 300 properties that we had to go to. So it wasn't the most efficient process, obviously, just because there was so much data. But because we're maintaining it daily, that definitely helps with keeping it up to date.
Hey, awesome. Is that one live? See it out. Just want to give me the link. The story map, I can share that with people. And that's what we got for now. All right, thanks, Aryn. That was really great. This time I'm going to turn on my video so people can see me instead of just seeing my black screen. So next up in our lineup is I don't know about you guys, but it's kind of weird to not hear the clapping and everything when we're doing video. I'm looking forward to us being in person next year, everybody. Okay, just want to say that. So next up, we have Ellen Carroll and Chris Ferguson. I'm going to let them introduce themselves, but they're going to talk to us about using GIS to map the storm drain system at Luke Air Force Base. I'm going to turn it over to you guys.
All right, great, thank you. So hello and thank you for joining our presentation. My name is Ellen Carroll and I'm the Information Management Lead at Wood Environment Infrastructure Solutions in Phoenix. Presenting with me today is Chris Ferguson, our GIS Analyst and Field Data Collection Program Lead. Jeff Cargan, a Senior Associate Application Developer out of our Georgia office, was instrumental in developing the GIS automation tools in this project as well. So Wood is an engineering consulting firm with offices around the world. We work on projects for various sectors and industries and are always finding new ways to use GIS tools. And I have to say, one of the best things about my job is being able to help clients solve problems through creativity, collaboration, and the use of cool geospatial tool. And I have a feeling that most of you here today feel the same way. That's why this project that we'll be discussing today was so fun to work on. We recently completed a project for Luke Air Force Base located in Glendale, Arizona, where we integrated mapping, field tablets, and automation to map their stormwater infrastructure system. Okay, and then today's presentation, we're going to split it up into 5 parts. We'll start with the preparation of the data for the field. Then we'll get into how the field work took place. We'll outline our steps for processing the data back in the office, including creating the pipe features in GIS. And finally, we'll review the project deliverables and lessons learned. But first, a quick synopsis of the project scope. So we first developed and executed a work plan with the project team for performing survey, cleaning, and CCTV video mapping of storm drain infrastructure at the base. Using geospatial data provided by the base, our field team located, surveyed, and rated nearly 850 storm drain structures, which could include inlets, manholes, junction boxes, and then subsequently mapped approximately 104,000 linear feet of storm drain pipelines. To help streamline and automate as much of the process as possible, electronic field forms were created for the 3 phases of the field work. And again, those 3 phases were surveying, cleaning, and videoing of the pipes and the structures. We also used field maps using ArcGIS Collector and ArcGIS Online, which helped the field personnel navigate and locate the structures. And they were also able to update the status of the structures throughout the whole entire process of the field work. And then back in the office, custom GIS Pro add-in tools were created by Jeff, our application developer, to automate pipe infrastructure digitizing and QC processes to connect the structures, create pipes between the structures. And now I'll hand you over to Chris Ferguson, who'll be walking you through the details of the project work. Thank you.
Thank you, Ellen. Before starting this project, I didn't know much about stormwater infrastructure. So before we continue and dive into the presentation, here's some key stormwater infrastructure terminology that we'll be referencing throughout the presentation. The image you see here shows a basic underground stormwater structure, whether it's an inlet, outlet, manhole, or junction box. Water flows in from one or more pipes and discharges usually from one single pipe, as indicated by the blue arrows in the image. The top of the structure is at ground surface and will either have a grate or a lid, depending on the structure type. The depth from this lid to the very bottom of the structure is the full structure depth. Pipe openings at the structure will be referred to as pipe inverts or just inverts. The invert depth is the depth from the top of the structure to the bottom of the pipe invert itself. And finally, a sump is a measured distance from the lowest pipe invert to the bottom of the structure. And not all structures have sumps. Some structures have pipe inverts right at the base of the structure. So in these cases, those structures don't have sumps. So first, I'll discuss what we did to prep the fieldwork for this project. Luke Air Force Base provided their most recent stormwater infrastructure data in their Spatial Data Standards for Facilities, Infrastructure, and Environment format, or SDS-FIE for short, which is the geospatial standard format for the Department of Defense. The stormwater infrastructure contained individual feature classes for point structures, including inlets, outlets, manholes, and pump stations. To better manage this data in the field, the point features were all merged together, maintaining a field indicating the feature type, and then all features to be examined in the field were given temporary tracking IDs. This is because the base has unique IDs for all their structures, but they were very long in character length. So a shorter naming convention was discussed and agreed upon with the field personnel. Features were also given a status field to domain to indicate which phase of fieldwork has been performed, which includes surveyed, not surveyed, cleaned, videoed, and non-existent. These were added to a field map to be used on ArcGIS Collector and was then loaded onto the field tablets. In addition to field maps, electronic forms for survey, cleaning, and camera work were generated and filled out using DO forms, which we will discuss a little more in detail later. As wonderful as all this technology is, a set of paper maps were also generated for our field teams in the event that anything went wrong with the field tablets. An online dashboard was prepared using the ArcGIS Online web app builder. This dashboard had a map of the stormwater infrastructure with each feature symbolized by their project status, as well as easy-to-view graphs of the overall status of field work as shown here. As the field personnel synced their data updates at the end of each day, the dashboard map and graphs updated as well. Project managers were given viewer accounts for ArcGIS Online in which they could log in anytime and view the status of field work as recent as the prior day. So here's a quick slide illustrating the full dashboard that was generated for project managers. The client did ask that in this particular presentation that none of their geospatial data be shown, so we blurred out the map portion of the dashboard. But the widgets, starting from the top left, show the structure status, which indicates how many structures have been surveyed, cleaned, or cameraed. Then they also have the pipes or the storm sewer lines. We have two different legends, one legend dedicated to infrastructure data and a separate legend that represents all of the field status colors. That way the project managers didn't have to scroll through one very long legend to learn what everything indicated. And then finally, a layer list that project managers could turn on and off to help them navigate throughout the dashboard. Next, we will discuss how fieldwork was carried out with the field maps and forms we set up for the field personnel. So here's a quick look at the field equipment used in the field. The tablets we used were Samsung Galaxy Tab Active 2s, which are ruggedized field tablets. They are drop resistant up to 10 feet. They can withstand extreme temperatures, humidity, and altitude and still be fully functional, especially with this Phoenix heat. And they have a battery life of over 10 hours. And then to help navigate around the site, the tablets were paired with Bluetooth GPS units from a company called Bad Elf. For this project, we used their GPS Pro Plus units, which provided mid-grade accuracy while using Collector, mid-grade being roughly 2 to 5 meters, depending on the setting. These GPS units also have a long battery life of roughly 24 hours. That mid-grade accuracy is all we needed for the Collector part of it, because as we'll discuss a little later, we had a licensed surveyor come in and survey all of the locations of all structures at Luke Air Force Base. As we mentioned earlier, ArcGIS Collector was used for navigation around the site, as well as status updates of the infrastructure. The field team marked additional information in the comments section of the features, including any structures as needing traffic control for later phases of field work, or if the structure had a sump. While the field team used a Bluetooth GPS unit to help guide them around the site and update the infrastructure status, a third-party contractor was brought on to collect survey-grade geospatial locations of each structure, which they later provided the location data to us for mapping. The other software used in the field is a desktop site and mobile application called DO Forms. The desktop site allows us to take any paper form and make an easy-to-read electronic form that can be loaded onto a mobile device through the mobile app and fill them out without the need for a data or Wi-Fi connection. Forms, however, can't be sent back to the desktop site without a data or Wi-Fi connection, which the field team had at the end of every field day. These forms are used to collect physical attributes of the structures, including dimensions, depth, invert count and directions, pipe diameters, material types, and conditions. Each form was also set up to allow for photo attachments as well. Next, we'll discuss communication with the field team. The GIS team was in daily contact with the field personnel as needed throughout the 6-month duration of field work. During this time, it was quickly communicated with us that we had too many forms to fill out for a single structure, and it was slowing down the field crews. Initially, we thought it was beneficial to have one form filled out for each structure, and then individual forms filled out for each pipe opening at a single structure. After a lengthy conversation with the field team after day 1, we discussed what the most crucial field data that was needed to be collected at each structure, and then merged all survey forms into one form to be filled out at each structure. The field team confirmed this greatly decreased time spent at each structure, and fieldwork continued at a reasonable pace, as well as this minimized the risk of transcription errors post-fieldwork. As fieldwork progressed, the field personnel expressed a need for additional spatial data they believed would be beneficial for later phases of fieldwork. First, they requested a new feature layer of traffic control features, which indicated any structures that would require traffic control to safely conduct the cleaning and videoing phases of the structure. Additionally, structures with sumps were requested to be shown on the field maps. This was beneficial to have on the field maps during the CCTV phase of fieldwork, so as the camera operator does not drive the camera off the edge of a pipe opening and potentially damage their equipment. To help fill in occasional field schedule gaps, I myself volunteered to spend a couple of days in the field when needed as well. I personally have a background in field work from a previous career, and with this, this provided an opportunity for me to see for myself the workflow that I created for the field personnel and verify everything was working as it should. And it was just fun to get out of the office every once in a while. Now we'll discuss how the field data was managed back in the office. As we mentioned before, our field maps were used primarily for site navigation and status update. The third-party surveyor provided the geospatial structure locations on a regular basis in tabular format. Survey forms from due forms could be exported both as individual forms as well as a CSV file of all the data collected for a single form type, whether that be the survey, clean, or camera form, with data from a single form listed on a single row of the CSV file. Photo attachments could also be downloaded from the form as well separately and stored in a database. The image here shown is an example of our stormwater survey form generated with due forms, where our field personnel collected the physical properties of each structure, gave them a condition rating, and collected each invert's physical properties as well. Once we had the geospatial locations from the surveyor and the CSV file of all attribute information from due forms, the two datasets were merged together using an ArcGIS Pro tool built by our application developer out of Georgia to create a new dataset of high accuracy structure locations with the field collected attribute information for all of our structures. The reason for building a tool to merge all this together was because, as mentioned earlier, the geospatial data was provided on a scheduled basis, and the due forms data could be downloaded at any time by us. So the process of merging the spatial data with the attribute data happened a handful of times during the duration of the project, and the tool allowed us to click a single button, point to a few file paths, and in a little bit of time, a new geospatial data set was generated for us. There were several scenarios where structures could not be surveyed by the survey crew. Either we had vehicles or storage containers parked on top of the lids or grates of the structures, or in a few other cases, structures were entirely buried, in which there is no grate or lid at the surface. These buried structures were found during the camera portion of our field work, where the CCTV camera noted the distances from one structure to another. And after reviewing our known structure data, we realized we came up short of the structure we were expecting to find, and realized this is a new buried structure that we couldn't see from the surface. In these cases, the locations of the buried structures were approximated by using the distances from two known adjacent structure locations to the unknown structure and plotting the structure at the intersection of the two distances. Pipe slopes connecting to these buried structures were also estimated, which we will discuss further in the next section. So now that we have a new data set generated of all of these structure locations, the next step was to connect them all with pipe features. Manually digitizing individual pipes from one structure to the next and filling out all the attribute information was realized early on to be a long, budget-consuming task. With the help of our applications developer, he developed an ArcGIS Pro add-in tool using Microsoft C# and the ArcGIS Pro .NET Software Developer Kit that would help us with the pipe creation. So a quick note before I continue on, as I mentioned, we had a survey crew getting the high accuracy geospatial data, and then our personal field crew collecting the physical attribute information. Both survey crews collected invert directions, which would help us as a QC step to ensure we match up the correct invert information from the two different data sources. So the user of this tool would select the two structures that would have one pipe connecting them both, and then click the load structures or load selected structures button at the top of the tool. The structure attribute information would then be populated within the tool. To connect the two structures, the user first needed to assess which invert from each structure will be used to connect the two structures. The user would look at the first structure and then decide the direction needed to connect to the adjacent structure. If the adjacent structure is to the south, they would pick the invert from the first structure with a south-facing invert. So now that they know which direction they're going, they first select the due forms invert information of the desired location. Then they pick the matching invert from the survey crew's data. And then once all invert data was picked from the first structure, they would then look to the adjacent structure and pick the two matching invert directions that would connect the two structures together. In this case, the adjacent structure was to the south of the first structure, so the invert information needed would be the north invert information. With the invert data selected from both structures, the user would then hit the Create Pipe feature button, and a new pipe connecting the two structures would be digitized, automatically populated with the upstream and downstream depths, pipe diameter, and pipe material types that were listed in each structure's associated invert. If the chosen inverts from the two structures had mismatched pipe diameters or material types, the tool allowed you to add pre-populated notes in the comments field for the pipe data set, or you could add your own custom notes as well. The developed tool saved hours of manual digitizing of the pipes, but this tool made two assumptions. The first assumption was that the pipe was a straight line between the two structures. This was true for most of the pipes, but there were a few exceptions that required manual adjustments. Our field team noted in the camera forms any bends in the pipes, changes in material types or diameters, along with distances to the anomaly from their starting structure. This allowed the GIS user to make manual adjustments as needed. Distances to varied structures were noted in camera forms, which aided in approximating their locations. And once pipes were connected to these buried structures, depths of the inverts at the buried structures had to also be estimated. This was done by using the known invert depths of two adjacent structures to the buried structure, calculating the linear slope using the total distances of the two connected pipes between the known structures. Then, agreed upon by the client, we assumed that the slope is linear for the entire length of pipes. The distance from one known pipe to the buried structure was then used to reverse this formula, assuming the same slope, and the depths of the buried structures could be calculated from the reverse of that formula. The second assumption or limit of the tool was that a pipe needed two structures to connect to. Again, that was pretty standard, but there were exceptions. It was noted that a handful of pipes started at a structure, but ended at an intersection with another pipe without a structure. So a similar technique of estimating the intersecting depth was also used in this case. The client also requested that any pipes that have a change in diameter or material type be split at the change and be treated as two or more pipes between the two structures. The image you see here on this slide is a perfect combination of the majority of these listed adjustments. For one, the different colors indicate a change in material types. Starting from the structure to the right, going to the left, there is a bend in the pipe. And at the southwestern end of that pipe, it intersects with the adjacent pipe in the middle of the pipe, not at a structure. Once all the pipes were generated and adjusted, pipe checks were run also using a developed tool by our applications developer. The tool ran major checks to review spatial integrity, including larger diameter pipes discharging to smaller diameter pipes, structures with no discharging pipe outlets, negative slopes, and mismatched flow directions based on invert elevations. Any flagged structures or pipes were revised by the field personnel, and in some cases, the survey crew were asked to review their invert depths as well, and all necessary adjustments were made. In addition to providing a revised geospatial data set to the clients, ratings for all infrastructures were provided. Structures were rated by our field team, and pipes were rated by the CCTV operators using the Pipeline Assessment and Certification Program Criteria, or PACP for short. They looked for any infrastructure damage and operational blockages, including cracks and bulges in the pipes or major debris blockages requiring heavy cleaning. Cleaning of the pipes was performed during this field work, but some blockages required heavier cleaning, which would take place at a later time. All ratings provided by the CCTV crew were translated into a corresponding condition assessment that was more in line with the client's asset management program called Builder, and then joined by a table to the pipes feature class, as well as provided as a standalone table to the clients directly. The final section of this presentation, we will review the project's final deliverables and takeaways. After data checks were complete on the GIS data, the final step was to convert all of our data to the SDS-FIE format. Our applications developer was able to map out the necessary conversions for each field needing to be populated to streamline the conversion process. In addition to final GIS deliverable, all survey forms, cleaning forms, and camera forms populated in due forms were downloaded and saved as a separate appendix to the final report. A technical summary of the GIS process was provided to the stormwater engineers compiling the final report for the client, along with final figures showing the locations of structures and pipes with their field ratings and areas of potential drainage concerns. The objective of the deliverable was to help the base identify and prioritize maintenance needs. Here are some of the takeaways we had from a technical perspective. As I mentioned before, we thought we needed several forms for a single structure, but the field team communicated with us the need to combine all of these to help with the timing at each structure in the field. So after day one, we got on a phone call with the field personnel, discussed the major needs for each structure, and were able to create one easy to fill out form for the rest of the project. And the field crew did verify that on day two, with using the new form we generated for a single structure, that time spent at each individual structure greatly decreased. Another takeaway was regarding how the geospatial data was created and how we wished we had thought to create a network data set with the collected structure data. This would have aided in quicker turnaround times with the pipe data checks. However, network data sets require points at the start and end of all polyline features, and we weren't sure if the final SDS-FIE format for the base would allow for extra points like this if they did not represent actual existing structures. One final note, the key to a successful GIS field project is that the tools work for the task. You can develop an amazing tool, but if it's not working for the people using it, then it's not very useful. So always communicate with your field personnel and create a manageable workflow that benefits both the office people, the office GIS people, and your field personnel. I'm now going to hand this back over to Ellen, who's going to close us out. Thank you.
Thank you, Chris. As you can see, this was a very detailed project that required creativity, ingenuity, and good communication skills. The team did a great job keeping in touch with each other to make sure things were working. And as the technical lead for this project, I had to do some convincing of the project managers to go the tablet GIS automation route. We've done similar work in the past, but it was very manual. It was successful, but it took a lot more work, digitizing and hand transposing things. And then also technology has changed over time and we've changed with it. So thankfully the project managers trusted us and our vision in the project was a success. And I know some of you here are also in the convincing or selling position in your organization. So be sure to present the benefits of using technology to improve existing processes, tell them why it will benefit the project, how it'll save money or reduce errors or save time, rather than it just being cool and techy. That's probably the biggest takeaway there. So thank you so much. This concludes our presentation.
Thank you, Ellen and Chris. That was another fantastic presentation. I'm just amazed at all the great stuff that's been going on. We did have a question in there about how long did this project take altogether? You can answer that real quick.
Let's see. I know fieldwork began December of 2020 and wrapped up around May or June of 2021. So fieldwork was at least 6 months. I would say we had about 2 to 3 months to prep the fieldwork, and then after fieldwork, there was another, I want to say at least another 2 months of processing the data and compiling everything together. So altogether, I would say at least 10 months altogether.
And that included time for the project team to actually compile their report and recommendations to the base as well.
Okay, great. I'm not really seeing any more, and the chat automatically closes, unfortunately, right at the end of the session. So without further ado, so I think we'll wrap up. If any of your attendees have additional questions, again, you can, post this in the chat before it closed. If you want to connect with any of our presenters here today in this session, you can do so going to the community and then attendees. And assuming they've made themselves visible, so all of my presenters here, go to that section as well and make yourself visible. A little box will pop up right when you go to the attendees list. And people can message you and you can connect that way. So I want to thank everybody for attending, and especially thank our presenters. Again, this is one of my favorite sessions, is seeing what's being done with GIS, and there's so many great things going on. And you guys have so many great projects. I can't thank you enough. And so thank you for attending.
Thank you.